Today we enter the quantum world where we can look at things that comprise atoms. Let's take a look at this specific particle. This particle has zero spin. Spin can be loosely defined as a permanent quantity used to describe electrons. An electron can either be spin up or spin down. Now over time, this particle will decay into two different particles. These two do have spin, and we can measure these particles to see whether or not they're spin down or spin up. But before we measure, each particle has a 50-50 chance of either being spin down or up. Now since spin is permanent, once we measure one particle and it turns out spin up, the other one has to be spin down and vice versa. This means we can obtain information about both particles even if we only measure one. These two can now be labeled as entangled, and this phenomenon is called quantum entanglement. This entangled state remains even with vast distances in between them, even all the way across the universe.
How do you know they're not communicating beforehand?
Great question. Einstein thought the same thing and even wrote a paper on it, describing entanglement as spooky action at a distance. But after many years and experiments, we now know that these two are actually not communicating at all. Entangled particles can't be seen as independent objects. Turns out there can be connection without communication. Nothing spooky about it.
So what?
Well, entanglement can be used for things like quantum cryptography, where we use these particles for sensitive processes like voting, financial transactions, and other things you might want to hide. So before you dismiss all of this as mad scientist gibberish, give it a chance. It might play a bigger role in your life than you think.